Okay, so for our group for number one, so what do you think about this question, Brian? Are you good with it?
I think so.
Okay, and what about you, Scott? How are you doing?
Yeah, I think I'm good with it.
And what about you, Hung?
Yeah, I'm good.
Okay, well then Brian, do you want to tell us what you did and how you interpreted the question?
Well, what I did, I just it says how much will be demanded if a buyer pays a unit of 6. So I just plugged in 6 into PV, and I solved for QV. I don't know if that's right.
Yeah, and what about you, Scott? How did you?
I shifted the entire demand curve down, and I got a new function by having PB equals 51 minus the tax.
Okay. Yeah. So yeah, I don't know if you understood what Scott did, Brian, but because it was Brian that said that you did the shift, right, Brian? Or no, Scott, you said you did the shift.
Yeah, I did the shift.
Yeah. So Brian, these are questions where you have to shift the demand and supply curves. Okay, just putting that out there in almost all cases. Okay. And what about you, Hung? Did you do a shift too?
No, I got no idea to do on this question. I have find the quantity equilibrium and the price too, and then I draw the graph, but I don't know where will be the tax will be located on the graph.
So I'm gonna share the whiteboard, and so yeah, so let's talk. Remember, I told you all, like, the first step that I recommend in all of these is go ahead and shift and go ahead and graph the problem, right? So I don't know, is that what you did, Scott? Did you graph it? Or
yeah, I went ahead and graphed it first.
Yeah, so yeah, that's the right approach. And so Brian, let's talk for just a minute. I'll walk you through this. I'm gonna graph dollars because that's the units in which we're measuring price on the vertical axis and quantity here. So you hear, Brian?
Yeah.
So how should I begin graphing this one?
You could start off by labeling the y-intercepts for both PV and PV.
Yeah, so for the demand curve, what should I put the intercept as?
51.
51, right? And then down here I should do 4, right?
Yeah.
And so then I'll go ahead and illustrate. And again, I call these, I mean, I know I've been saying graphing, but they're really illustrations because I'm not doing everything to scale. I just know this one's going to be downward sloping and this one's going to be upward sloping. So at some point they're going to cross, and that's going to be our equilibrium, right? And so eventually we're going to want to know the equilibrium price and the equilibrium quantity. So I'm just going to kind of put that out there. But it turns out for this particular problem, we're not focused on that one. So, but what we want to do is we do want to go ahead and see this. It says how much will we demand if buyers pay a per unit tax of 6. So that would be a $6 tax. And we haven't talked about this yet in lecture, but then you end up drawing this thing that I'm drawing here in purple, okay? And so I'm going to call this one the regular demand curve. So I'll put a little label down here. This is our regular inverse demand curve. And this one is going to be our inverse demand curve minus the tax. Okay. And that's going to be our effective demand curve. Okay. And so now we have to kind of like parse this a little bit, because it says how much would be demanded if buyers pay a per unit tax of 6. And so, Scott, how did you interpret that part of it?
I figured then the maximum quantity would also go down by 6, and I suggested the function to fit that.
Okay, so what answer did you come up with?
My new quantity, I think it was 5.85.
Okay, and so do you want to tell us a little bit more explicitly how you got it?
Once I had my new function for d minus tax, I then set that equal to what the supplier has for PV, and that gave me my new quantity Q.
Yeah, so what you ended up doing, right, is you found out this new equilibrium quantity, right? Yeah. So what I have labeled in orange, a lot of people, and I often refer to it as the after-tax equilibrium. Okay. But I just want to point out that something kind of interesting happens here, and that is that if that's our after-tax equilibrium, then the way that we interpret it is you have this normally we say the equilibrium is a price at which quantity demanded is equal to quantity supplied. And so that defines equilibrium. And we should kind of, you guys have had a discussion topic on this, but so what do you think that equilibrium means generally, Scott?
It'd be the balance.
The balance of what?
The balance of what is being supplied.
Yeah, in this context, right? Yeah. So I think you said it, and let me just be explicit. What we're balancing, because equilibrium is this general concept that's used in a lot of different contexts of two forces being in balance with one another. So, you know, for example, you guys probably have heard in basic physics, every action has an equal and opposite reaction. So the forces come into balance, right? So, for example, Scott, does that sound familiar to you?
That's a good way of putting it.
Well, I mean, it's not me that put it that way, but I don't know if you.
It's like it's a general way of looking at it.
Yeah, that's the way that they normally express it in physics, right? Is that every force has an equal and opposite. Every action has an equal and opposite reaction. So have you heard that, or no? That's not like in your wheelhouse. I don't know when the last time you took physics.
Oh yeah, no, I've heard that before.
Yeah. So, and I think it's kind of interesting, like to think about that. So we have this kind of general concept. So, like here, I'll do the Scott stick figure. Okay, here's Scott. So this is you, Scott, and you're pushing against this wall, right? I don't know if you do that a lot. Go over and push the wall, right? But if you do that, right, you're applying force to the wall, right?
Mhm.
And the wall doesn't move usually, right?
Yeah,
And
normal
that's
force.
it was, yeah, and not your super force. but the wall's pushing back on you when you're pushing on it. So there's balance between the forces. But here's the thing, so does that make sense? You push on the wall and the wall pushes back on you.
Mhm.
Okay, now here's the thing that how does the wall push back on you?
It doesn't, that's just the normal force. Eventually, because I'm pushing against it and we're going to reach some equilibrium, either I'll push through the wall or will it just be a balance of forces.
Well, yeah, okay, but see, so even if you push on the wall just a little bit, the wall's going to push a little bit back on you. But how? Where does the wall? I mean, you know where you're getting the force from, right?
Mhm.
You're activating your muscles and you're pushing. How is the wall pushing back on you? The wall doesn't have any muscles.
Geez, what would be like the friction of the molecules of the wall?
Yeah, so like the strong and weak nuclear force that's bonding all of those atoms and molecules together, right?
Mhm.
When you try to move them, and you could call it friction. I'm not a physicist,
Good,
so
me too.
I don't know the whole explanation, but the gist of it is that you know all of those atoms together, when you do try to push those bonds apart, are going to resist that with their, again, strong and weak nuclear force that wants to keep the bonds intact. So yeah, there's friction, there's, the that force there that's going to resist you, and you could eventually, yeah, like break through them, and wouldn't mean that, the forces then at that point would be out of balance, right? But eventually, if you kept pushing, you'd hit something that you couldn't push anymore, and whatever, then they'd be in balance. But it's a balance of forces, and a lot of people in economics, they talk about the tendency of demand, and they'd express that as, the forces of supply and demand coming to balance. But I really don't like that analogy, because it seems like there's a much clearer one in our context, which the balance that's being achieved is simply the balance between quantity demanded and quantity supplied. And so, yeah, so in our context, equilibrium means that quantity demanded is equal to quantity supplied, and then you normally, reflect on the prices, but it's not, the prices are kind of giving signals for people to adjust their demand and supply when there's nothing interfering with them when there's not a government price ceiling, which would be an artificial, right, price. And so people don't necessarily react to it in the way that they normally would, adjusting how much they want to buy and how much they want to sell. But under normal circumstances, right, in quote free market where people get to make their own decisions, those prices guide them such that they balance how much they want to buy with how much they want to sell, and then the prices stop adjusting and the quantities are in balance with one another. So our balance really is anchored by this idea that quantity demanded comes in to balance with quantity supplied. But here, right, in this after-tax equilibrium, the thing that's interesting is we have quantity demanded and quantity supplied coming into balance, right, Scott?
Yeah.
Right, we have that balance, but the price signals are going to be different. Okay. So when we think of price is, and the reason why I'm spending a little bit more time with this is it's our first question, and all of this is going to become relevant when we answer questions later on down the list of questions we have on this particular assignment. So it's going to be important in almost every instance. We're going to want to identify this after-tax quantity, and I'll just kind of mark it down here, right, at which quantity demand and quantity supply come into balance. And I'll call this one QT for the after-tax quantity of the good that's traded. And then we're going to end up with after-tax price that the buyer is going to pay, and I'll call that BT. And there's going to be an after-tax price with which the seller is going to receive. Okay. So, and they're not going to be the same. And so we have to kind of reflect a little bit on what we mean by price. Okay. The buyer's price is actually the amount of money that the buyer loses as a result of the transaction. It's what comes out of their pocket. So when we talk about this particular price, okay, a lot of people would say, well, that's the price including tax. That's a little imprecise, because as we'll find out a little bit later, it turns out that the tax affects both the price that the buyer pays and the price the seller receives. But what is true is that if we look at this buyer's price with respect to the seller's price, it's always going to be the case that PVT plus the tax is going to be equal to PB. Okay. So anyway, so let's go back a little bit and just look at your math, Scott. And so if we go ahead and do this, so one way that you can do it is just what you did. I'm gonna modify both sides of the equation for the inverse demand curve to reflect the tax, right? So then I'll have balance, right? So in algebraic terms, I'm saying 5 times QB minus the tax. So how does that equation look to you, Scott?
Yeah, that's roughly what I did.
Yeah, and so what I do is then I would just relabel this as PBT right? And then I'll group things accordingly, which is, okay. So that looks good, right? And now we know that the tax is equal to 6. And so our new effective demand curve with the tax is the 51 minus the 6, which is 45 minus 5 QB. And that's what you used, right, Scott?
Yeah.
Yeah. And so then we're going to set that equal to supply, and then we'll get that point of intersection. And actually, I'm going to write it this way because it's going to help us a little bit with the little bit of algebra that we have to do. Okay. So does this make sense to you, Scott?
Mm-hmm.
Yeah. And then since we're looking for the point where the lines cross, that's our equilibrium, I can go ahead and just say, I know at equilibrium that QT is going to be equal to QV, which is also going to be equal to QB. Okay. And then finally, I can go ahead and substitute QT in for all the QBs and the QVs there. And I'll end up with this, which is 45 minus QB, 5 QB, but now it's going to be QT, is equal to 4 plus 2 QT. And then I can solve for QT. And this is what you got, which was QT is equal to, and let me move this around a little bit. It's going to be equal to 45 minus 4 divided by 7. Right? Do you agree? Is that what you got on your calculator?
Yeah.
Okay. So that's 41 divided by 7. I'm doing it on my calculator right now. And so, yeah, so if we do it in decimal terms, I get 5.857. 142. Okay. And yeah, that's going to be equal to how much the buyers actually want after the tax, and also how much the sellers actually want to sell after the tax. And so I'll go ahead and grab the answer from Ignithium so you all can see. Okay. Good job, Scott. Does anybody have any questions about this particular problem? No. Okay. So let's go ahead and take a look at the next one. All right. Okay, so for there, our group is Wombly, William, and Alex. So Wombly, how are you feeling about this question?
I similarly, it's like the last people I got to the point where I found both equilibriums, and then I kind of just got confused as to where to plug the taxes in. So I saw you write that equation down and I wrote it down, but I just didn't finish it. But I graphed it as well.
Okay, okay. So you graphed it. What about you, William? How are you feeling about this one?
I'm feeling pretty good.
Okay. Did you come up with an answer then, William?
Yes, I did.
Okay, so what answer did you come up with?
I got 6.7.
Okay. And what about you, Alex?
I got the same answer.
Okay, okay. So Wombly, was that one of your answers, the 6.7?
The 6.7, I got 7.7 for my Q star and then 19 for my P star, but I could have messed up a little bit, so I'm unsure.
Yeah, well, again, so let's go ahead and walk through it, Wombly. So our first step is we want to graph it, right? And so do you want to tell me how I'm going to begin graphing this like I did with the other one?
I mean, yeah, I would put the supply curve, which would be the 58 minus 5 QB, and then the demand, the 4 plus 2 QB.
Okay. Just to be clear, right? You're a little bit mixed up. So the demand is the 1C with the B for the buyer.
Yeah.
Okay. So let's do that one first. So what should I label this intercept then for the inverse
That
demand
one would be
curve?
like P for the price, and the manual would be quantity.
Yeah. So, but this intercept for the vertical intercept of the demand curve is at what value?
Oh, 58.
Yeah, 58. Okay. I'm gonna leave the dollar signs off just to make it a little bit quicker. And then for the supply curve, the vertical intercept. Oh, let me see if I can do it in that. Okay, this one should be at what value? The vertical intercept.
That one would be at 4.
Okay. Now, this time, right? We have this, seller is going to pay a tax of 7, so that's $7. How should I illustrate that?
It will be a shift in the supply curve to the left because there can be less people wanting to supply it.
Right. And so it's going to be like this. And do you know what the value of this intercept would be?
It would be just 11.
Yeah, we're just going to shift the supply curve up by the amount of the tax. So it's 4 plus 7, so it's 11. And then we're again going to look at the after-tax equilibrium, right? Which is where those two cross. And again, our focus is going to be on this after-tax quantity down here, right? So what did you get for the after-tax quantity?
I didn't get that far yet. So
Okay, so just to be clear, and hopefully this makes sense. So our PV after tax then is going to be 4 plus 7, the amount of the tax, right? Plus 2, and we can call it QV if we want to, or QVT. Doesn't matter as long as we're clear about what we're trying to illustrate. So does that make sense? Warmly?
yes, that does make so much sense.
Okay. So I just added the tax, and since the tax is a constant, it just affects the intercept term. Okay. And now again, we want to look for the equilibrium. And so the equilibrium is going to be where PB is equal to PVT, that's the after-tax equilibrium. And so we're gonna have 11 plus Q or 2QB is equal to 58 minus 5QB. And then because we know we're looking at the equilibrium quantity again, I mean, hopefully this is clear, but we know our after-tax quantity is gonna be the same for QV and for QB. So we can just substitute down here the same variable name. Okay. And then finally, we can just solve that equation, which just has QT by itself. So do you want to work on that really quickly and then tell us what you come up with?
Yeah, I got like 6.714 about.
Okay.
So that's where they came. That number makes sense now. I understand.
Okay. Yeah. So this is the calculation that you just did. It's going to be 58 minus 11 divided by 7. And you said that's 6.71. Is that right?
Yeah.
Okay. And I'll put the hint down here. Okay. Clapping for you all. Good job. So yeah, so that's the after-tax equilibrium quantity. And that's how you find it. Okay. So we have a few minutes before we're gonna begin the main lecture. If you all don't have any questions at this point, then I'll go ahead and say goodbye for a moment, and I'll be back in a few minutes. Okay. Anybody have any quick questions? No. Okay.